Hello and welcome to SudoKanard. We're here to solve this puzzle of mine called 3 is a crowd Sudoku. This is a quite ancient variant of Sudoku, but one you don't see so often. And actually, it can be a little tedious. So, what is the rule? It is very similar to outside Sudoku. In outside Sudoku, those 3 digits would have to be those 3 digits. But you can see that those would have to also to be those 3 digits, which doesn't work very well. So what's the point here? The point is that in every triple digit that is given as a clue, one of them is wrong, one of them is a liar, and of all 9 clues here, all 9 liars must be different. So in all those clues, so every time 2 of them are correct and must be placed in here, the other one is not correct, and I will place it here for as a reminder. And all of them on this side of the board must be different, and the same is true here, and the same is true there. So I will put the link in the description to the PenPal interface so that you can try this puzzle for yourself. And now let's start solving, and I will just state that I created this puzzle a long time ago and I don't quite remember the solving path, so it will be like something new. Well, what I'm seeing at first is that here you can see that 6 appears twice in those clues, but 6 can't be both here and there, so one of those 6s must be a liar. And as a result, this 6 here, because there is a lying 6 in here, all other 6s on this side of the grid must be correct. So I will pencil mark this like that. There must be a 6 in here. There must be a 6 in there. Let's do the same for other repeated digits. So 3 and 7 are repeated in here. So there will be a lying 3 and a lying 7 in there. So those 3 and 7 must be true. And therefore the liar here is the 1. And therefore this one must be true. And this one also must be true. So this is something. And I said that a 3 here must be the liar. So the 3 here must also be true, so that the liar here is the 2. What's happening? The liar here is the 2, which means that 2 is not there, but it can still be there. And it means that the 2 here is correct, and the 2 here is correct. So that's the start. Let's move on with this logic. Here there is a lying 5 somewhere, so that the other 5s in this area must be true. So this 5 here must be true. In this part there is a lying 3, so that the other 3 must be true. So there is a 3 in here. And I will mention something, which is that one of those 3s is a liar, but the other one must be true. So the 3 will either be here or there. I can remove this pencil mark. So there is a 3 here. I can remove this pencil mark and this pencil mark. So there is a lying 3 in here. So this 3 here is correct. So that the liar here is the 6. And this 6 here will be correct. This 6 here will be correct. And this 6 here will be correct, so that the correct 6 is actually here. And I can remove this pencil mark. And I can also remove this pencil mark and this one. So 6 is the only repeated digit in this area. So let's move on to the bottom. 8 is a liar. 8 will be a liar somewhere here. so that this 8 here is correct, and this 8 here is correct. This is the only repeated digit down there. Here 9 is repeated, so one of those two 9s will be a liar, and the other one will be correct. This 9 here is correct. And there is no 9 in the clues here. Now we can see that because there is a 6 in here, we can see that this 6 here is a liar. So 4 and 5 must both be here. And I have to address this. So this 6 is correct. But I need to, sorry about that, I forgot to process those clues. We can see here that 3 and 5 must both lie in those cells. So this 3 and this 5 are liars. So we know that the correct 5 will be in one of those two cells, and the correct 3 will be somewhere in here. And we can see that 4 here is correct, so that's the 4. And now, because of this, the correct 5 is in here, so that the liar here is the 3, and here it's the 5. Now 3 is correct in one of those cells, but there is a 3 in here, so the correct 3 is in there. And we now know that the other two digits here will be correct digits from 1, 2, and 9, so 8 is not here. Those are from 1, 2, and 9. And an interesting point is that here we can see that one of them at least is a 1 or a 9. So the digit here, which is a 1 or a 9, will have to be the liar on the other side. And the same happens the other way, meaning that if I tried to have both 1 and 9 correct in this area, then they both would have to be liars in this area, which cannot happen. So the liar here is 1 or 9, and there is a 2 in here, and there is an 8 in there. And we have a split pair of liars on both sides of the grid, where here the liars were just side by side. Now let's get back to this 3 and this 5. We now know that this 5 here is correct. The 5 here is correct, so that is a 5, and the 3 here is correct, so that is a 3. We can remove some pencil marks there. And because of those 3's, we know that there will be a 3 here, and because there is a 3 up there, there will be a 3 here down there. All right, so now because of this 5, we know that this is the 5. We know that the liar here is 2 or 4, and in this area, the liar is also 2 or 4. So we have a pair of liars, and we can see that actually no other clues remain with a 2 or a 4, but I'm saying that this here on this side is now the only one that can have a lying one, and we know that 1 must be lying somewhere. So the liar here has to be 1. And we can deduce from that 6 and 9 are correct. And because there is a 6 here, that's not a 6. And because there is a 6 here, that's not a 6 either, and that is a 6. And because of this 6, on the other side, we know that the liar is a 6. So there is a 6 in here. And because of this lying 6, 6 is not correct. The liar will be from 4 and 5. And what did I do? Oh, I pencil marked a 6, where I should have pencil marked an 8. 8 is correct. 6 is correct in this area. And we can see from those that 8 will have to be here. Perhaps it will be useful at some point. Probably it will be useful at some point. And I should perhaps pencil mark the limitations on layers here. And I'm seeing that on this side of the board, the only place where 9 can be a liar is here, which is the kind of logic I applied here with the 1. And that's interesting because, well, actually, this is something I could have noticed right from the start. This was the only 9 on this side of the board. And now that we have those pencil marks, where can 8 be a liar? Well, only here. So 8 is the liar there. And now that this is out of the way, 3 can be a liar only here. And this is a liar from 4 and 5, which means that the only place where 7 can be a liar is here. So now we have a 5 somewhere there, which means that this 5 here is a liar. So that's not a 5. And this 5 is correct, so that's the 5. And this 5 now says that 5 is the liar there. So knowing that 5 and 6 are placed, 2 and 3 are in here, so that's the 3. 3 and 5 are correct here, so the liar is the 9. This 9 here is correct. The liar is either 7 or 8. Knowing that this 9 is a liar, the liar here has to be the 1, and here it has to be the 9. So we can remove 9 from the options here. And here, this 9 is correct. On this side of the board, right from the beginning, we could see that 4 only appears here. So 4 has to be the liar. And 3 is correct. 3 can only be here. So that now this 3 has to be the liar. 1 and 2 are correct. 1 is in one of those two places. 2 is in one of those places. So the remaining liars on this side are 2, 7, and 8. So it has to be 2 or 8 here. So that 1 is correct. That's the 1. This is not 1. And this has to be from 2 and 7. So that 6 is correct, but we already knew that. On this side of the board, the liars must be from 6, 7, 8, 9. I'm saying that this 9 here is correct, so the lying 9 can only be here. So that 7 and 8 are correct. So 8 has already been pencil marked. I'm adding the 7, and there will be a 7 in this region. So we are left with 6, 7, and 8. All 3 of them are still possible in here. So the liar here is from 7 and 8. The liar here is from 6 and 8. And this is not quite helping at this point. Here the liar is from 7, 8. Let's move on to this side, which I haven't used quite so much. So here 1 will be a liar somewhere. So this 1 is correct. That's the 1. And so the correct 3 must be here. And that's the 3. On this part, the liar must be 2 or 3. And we know from this that it has to be the 3. So there is a 2 in there. Actually, this turns that into 2. That's a 1. And there we have to be a 1 here or there, which is interesting because the one of the clues is a liar, the other one is correct. So this 2 here removes this option, so that is a 2 and that is a 2. 4 and 6 are correct here, so that's a 6, and that's a 6. And 4 is somewhere there, and with that we can see that this 4 here is the liar. And that's the 5, which is lying, so 4 is here, 5 is somewhere in there. I don't think I can find which one at this point. So what do we have? So 9 is the liar, 7 and 8 must be placed into those cells. 7 here must be somewhere here, and because of that it must be here as well, so that's a 7. This region still needs the 9, it's not here, because of that it's not here, so the 9 is here. Those must be 8 and 4. But there is a 4 in here, so that's 8, that's 4. 8 is removed from this place. So what should I see here? The liar is from 7, 8, 9, but 9 is not available, so the liar is from 7 and 8, so the 9 is in here. But we know from this liar that 9 can't be here, so 9 is here. It pushes the 5 into this cell, which pushes the 2, the 8, the 7, and the 4. That has really cascaded. That's not 8, this is 8. That's not 7, this is 7. This is 5. And here we need 1, which is not here because of the liar. And we need the 9. So now 8 is correct. The liar is the 7. And here 8 is the liar. So I can remove this 8, place this 8, remove this 8. And because of those pencil marks, I can remove this. That's an 8. Here I need 6, 7, and 9. Because of Sudoku, that's a 7. Here we get 6 and 9. But we know that here, now 7 is the liar, so 6 is correct, and that's the 9. So because 7 is the liar here is 8, and this one is 6. So that's not 6. 6 is there, and 6 is there. So 7 is correct. It has to be here, which places a 7 in there. Oops. Those are 8 and 4. Here I need a 1 and a 2. And just the digits that are already placed. Have to disambiguate all of that. That's an 8. 9 can only be here. So 8 is correct. The liar here is the 7. And I could have seen that 7 is not a liar here. The liar here is 8, and this is true. Here I need a 5. Here I need a 4 and a 7. But because 7 is lying here, that's the 4, that's the 7. Let's address this part. We still need 1, 2, and 4 there. That's the liar here is not 4. The liar here can only be 4. So 6 are 8 and 8 are in here. 6 can only be here. 8 can only be there. 4 and 7 are both. Oh, actually, this can only be 1. And the liar here is 2, so 1 is not here, 1 is there. So I need the 3 here. It's there. I need 4 and 7 here. 4 is there, 7 is there, that's the 2. And here I need 5 and 9, so that's 5 here and 9 there. That's not 9. 9 is here. That's the 3. That's a 2. So the layer is the 4, and the layer here is the 2. I have seen as much before. And now let's finish this with Sudoku. Here we need 1 and 4, but here there are layers. So let's remove those pencil marks and just see. Here I need 1, 8, and 9. So that's 9, that's 1, that's 8. Here I need 3, 4, 5. So that's 5, that's 3, that's 4. Here I need, well, that's a 2, that's a 7, and that's a 6. So this is a way to solve this puzzle of mine called 3 is a crowd. I did not create the variant. I just wanted to try to create such a puzzle, and it's really not that easy. It's really not that easy to create. It took quite some work to make it, to have it, and you can see that I started with those screws. 1, 2, 3, 4, 5, 6, 7, 8, 9. I thought it was interesting to just put them this way. Well, thanks for watching this video, and see you pretty soon, I think, on SudoKanard.